important part of chemistry is looking at solutions and the concentrations of solutions. And where we start off from firstly is looking at what these different definitions are. You may have come across them at GCSE, but let's just recap them. So we've got solute. Now solute is the salt or the substance which is dissolving, and it's usually in the form of a solid. And we have a solvent. A solvent is something like water in which the solute will dissolve. And when the solute dissolves in the solvent, it gives us something called a solution. So those are three important definitions you need to know. The next thing what you need to know is about volumes themselves. And in chemistry and in maths, 1 litre is referred to and equivalent to 1,000 centimeters cubed, which is also equivalent to 1 decimeter cubed. Whenever we quote volumes in these questions or questions which involve concentrations, we always need to use decimeters cubed, and I'll explain that as we go through. So, concentration, once we have our solute dissolved in the solvent, then we can work out the concentration of that solution. And we've got two very important equations here. In some textbooks, in some videos, they'll show you triangles, but I'm trying to stay away from triangles because I want you to look at the units, because the units usually help you remember the equations. So concentration can be the number of moles of that solute dissolved in a decimeter cubed. So it's the moles per decimeter cubed, and that's the units moles over decimeter cubed. And that's an easy way to remember how we can work out concentration when we've got moles. We can also work out concentration by looking at the mass, how much grams of the solute is dissolved in the volume in decimeters cubed. So we've got the units grams per decimeter cubed. So we can either look at moles dissolved in a volume or the mass dissolved in the volume of that particular solute. Another important part is being able to convert concentrations from the units of moles per decimeter cubed to grams per decimeter cubed. An easy way to go from moles per decimeter cubed to grams per decimeter cubed is by timesing or multiplying the moles per decimeter cubed value by the MR of the solute. If we want to go back from the grams per decimeter cubed back to moles per decimeter cubed, then we divide by the molecular mass of the solute. Okay, so they're the most important facts before we start looking at calculations. So, the next part of this particular lesson is to look at some of these calculations. As I've always said, make sure you underline what the key points are in the question. So it says, calculate the concentration of a solution when 2 grams of sodium hydroxide, and they've even given you the formula there, so that will help you, is dissolved in 50 centimeters cubed of water. Okay, so that 50 centimeters cubed is where we've got the water, and that's what it's dissolved in. Sodium hydroxide is dissolved in 50 centimeters cubed of water. It says calculate the concentration in both moles per decimeter cubed and grams per decimeter cubed. Okay, so the first thing to do is to work out the moles of sodium hydroxide, which we can easily do. We've got the mass, which is 2 grams, we've got the formula. So we can go moles of, and I'll put NaOH, we can use the formulas, is the mass over the MR. We know the mass was 2 grams. We're going to divide that by the MR. So to work out the MR from the formula, again, you will refer to the periodic table and look at the relative atomic masses. So the relative atomic mass of Na, which is sodium, is 23, oxygen is 16, and hydrogen is 1. And then that is there 2 divided by the sum of all the atomic masses of sodium hydroxide, which is 40, and that therefore now is equal to 0.05 moles. Okay, so we've worked out the number of moles of sodium hydroxide. So we can work out the concentration in moles per decimeter cube of that sodium hydroxide, because if we take the number of moles, which we've just calculated, divided by the volume of water, which we've dissolved in, we've got 50 centimeters cubed of water there, so that is 0.05, divide that by 50. Now something you've got to be aware of, that is 50 centimeters cubed. We want to convert 50 centimeters cubed always to decimeters cubed. So you want to go from 50 centimeters cubed to decimeters cubed. So you have to divide it by 1,000. So 50 divide that by 1,000 is 0.05 decimeters cubed. So I can even put it down here, 50 over 1,000. So that's 0.05. Divide that by 0.05 because 50 over 1,000 is 0.05. So we end up with 1 mole per decimeter cubed. So that's our concentration in moles per decimeter cubed. We want to work out the the concentration now in grams per decimeter cubed. Okay, so again, how do we work that out? So concentration in grams per decimeter cubed. So quite simply, we know that we've got is the grams, so it's 2 grams, and we divide that by, it was dissolved in 50 centimeters cubed. Again, that needs to be converted to decimeters cubed. So if I just put 2 grams, divide that by 0.05 decimeters cubed, and we'll end up then with 40 grams per decimeter cubed. So in this question now, we've got the concentration in moles per decimeter cube, where we looked at the moles and we divided that by the volume, making sure we divided the volume, if it was in centimeters cubed, by 1,000 to make sure it's in decimeters cubed. And we've also worked out the concentration in grams per decimeter cube by taking the mass and dividing that by the moles, and we end up there with 40 grams per decimeter cubed. And again, remember, converting that volume from centimeters cubed to decimeters cubed.